Practice Exam 2, Part 9.
Part 0.
We're on our final question of the practice exam, question 14. This one is pretty easy. I've got the conclusion at the bottom. It's not S and T. Okay, and these are your three premises. I'll move that down so you can see the conclusion once we get going. This proof is not too difficult. There's a couple of moves that could possibly throw you if you're not very practiced doing proofs, but not too much trouble. Okay, so take stock, look at both your premises and your conclusion and grasp what their forms is. Grasp what the forms of all these statements are, right? And be put in mind of the rules you're going to be applying. So just, I've got a negated disjunction, so yay, happy face, right? That's going to use De Morgan on that and then simplify. Got a couple of conditionals, okay? So I'm thinking the modus's, the modus ponens, the modus tollens. But where am I going? What do I need to get? Okay, my conclusion is a conjunction. So the question you just always apply is, right, what is the form of this thing? What rule gives you formulas of that form? This is a conjunction, so I have to think of rules that have conjunctions as conclusions, right? In this case, that's the rule of conj. So I'm probably going to justify this by conjunction, and then the next thought, right, what formulas do I need to apply that rule? And in that case, I need the two conjuncts. I need the two conjuncts separately. So I need to get a not S somewhere, and I need to get T, right? That's my thought. And then I just apply that thought again, if I'm working backwards. Not S and T. How do I get not S? Right? It's a negation. What kind of formulas? What kind of rules will get me not S? What kind of formulas will get me T? Okay, these are just atomic formulas. In one case, plus a negation. So let's start doing some top-down reasoning and see what we get. That's what we need. That's what we know. We know that's what we need to get. Not S and T separately, and we'll be home. So clearly, number one, right? There's obvious top-down reasoning to do on that. If you're familiar with De Morgan's, which you should be, you should see that and see an application of De Morgan's waiting to happen. Not R and not X. One De Morgan's, which leads me to simplify the next two steps, right? It's a happy face because this 4, 5, 6 should be a habit. It should be a straight up habit. You see a negated disjunction, even if it's complex, even if those disjuncts are complex. It could be not, and then a disjunction of A biconditional B hook C, and the other disjunct something else, right? But it's still a negated disjunction. You can still apply De Morgan's on it, and the result would be formulas much less complex than the very ugly complex formula you started with, right? Because look what happens, you simplify. You end with a conjunction, the result of De Morgan's is a conjunction, and you can simplify to get the conjuncts by themselves, right? Simp. All right, so one of the two tricky things that I mentioned about this one, not very tricky at all, it's just, you've got not R, right? Not R is going to be very useful. Notice that this is the negation of both of your conditionals, right? Both 2 and 3 have the consequent R. Yeah, that's right. So you've got the negation of both of these conditionals in this formula. So don't be afraid, don't think it's not allowed or anything like that, to apply modus tollens twice, appealing to 5 in each case. Right? You can do this. Okay, so 7. I'm going to do 2, 5, modus tollens. And what's the result? What formula do I derive from that? Which is terrible at quantified logic. All right, it's not brackets. It's the negation of the antecedents, not brackets. X or S, of course, right? That's another smiley face. It's a negated disjunction, so that I'll go ahead and.
That is definitely
7 De Morgans. Okay, I've already got not x, so I'll only simplify to not s. Right, not s, 8 simp, 8 simp, and notice, sorry, I should move this down by now, but there you go. Can you see 2? No, you can't. Okay, not s, so I'm halfway home, right? I've got one of my 2 conjuncts. My left conjunct is not s. Okay, I need to get t, and I'm home. Okay, so t is going to come from 3, clearly, right? So as I said, I had not r. I applied it to 2. Notice Tollens. I said notice Tollens yet. Let's apply it to 3 as well. Okay, so 9, 10. I'm going to do, what am I doing here? Modus Tollens to get not, so, and this is where the other tricky part comes, not t and not x, that is 3, 5, modus tollens. Okay, so the not t is going to come out of this, but this is another application of De Morgan's you have to do now. This is just a slightly tricky application of De Morgan's. There's a second tricky thing I mentioned, that you need to be familiar enough with the rule, you need to be well practiced enough with the rule that you can perform De Morgan's on this without too much trouble. It's just tricky because there's lots of negations, right? This is a negated conjunction, right? You have to think this of the form, not P and Q, going to not P or not Q. But now that becomes, since your P is not T and your Q is not X, 11, it becomes not T or not X, right? 10 De Morgans, right? Notice that's the second of the 2 forms of De Morgans. Look at the rule again, there's 2 forms of De Morgans. One transforming negated disjunctions, the other one negated conjunctions. Okay, so I've got a disjunction now. My result of this is a disjunction. Now, I have not x. So let me just transform this to not t or x, right? That's 11 double negation. Okay, I double negated this one. And now I've got not x at 6, so I'm going to use 6 and 12. 6 and 12. What was it on? 6 and 12 disjunctive syllogism. DS, right? But not x, that's the negation of the second disjunct, gives me 13, not t. Not t, by that rule, disjunctive syllogism. 14, t. That 15. 14 t, double negation on 13, right? And then conjunction of what? 14 and 9. 9, 14, conj. Change colours. All right. So many of you will be so if you got all those steps, many of you will be asking whether at 11 you're allowed to double negate both of those formulas with the application of double negation. Strictly no, right? You should do it on one side, but I actually wouldn't take off a point for that. But it's the only slightly deviation from extreme rigor which I'll allow. But you should just apply the rule once to one subformula if you're doing it. So I sort of did it properly for you. It's not t, it's t. Okay, that's that. So that's the end of those proofs. Now I want to end with a couple of final tips for you for the exam. Okay, so over here we've got just a couple of moves you should be familiar with, you shouldn't be scared of, right? Don't forget the rule of duplication, and that the rule of duplication, dup DUP dot is the ossification. Duplication has two forms. P is logically equivalent to P and P, and also P is logically equivalent to P or P, right? Conjunctions of a formula in itself, disjunctions in a formula of a formula in itself can be reduced to a simple formula. It's a replacement rule, so you can use it on subformulas. So don't be afraid to do something like this. If you've got a B or B here, right, as a subformula, say for example it's a consequent of conditional or whatever, or as a second disjunct or whatever, you can apply do and reduce this to A hook B. That's legal. Am I sure? Am I confident that it's legal? Am I confident that I'm not taking leave of being truth preserving? You can be. B is logically equivalent to B or B. Whenever this is true, this is true. Whenever that's false, and vice versa, right? So you're replacing, whatever the truth value of this is, you're replacing it with something with the same truth value. So that's logically equivalent to that. A hook B, hook B. You can reduce it to that by do. That's one tip. Second tip, Second tip is, what would you do in a situation like this? You got these two premises, A or B, and the disjunction of not B or A or F. Okay, ask yourself if you can see a move waiting to happen. Pause, see if you can see it. Unpause, welcome back. Yeah, there's a move you can make. You can get to F from here. How? You can get to F from here with the use of the rule of commutation, which is C-O-M-M. Okay? So 3, you could do it either way. You could commutation. Commute is swapping around. Look at the rule if you don't know what I'm talking about. You could do 1. You could do it here, or you could do it for B or A. Let me do it on 1. Right? B or A, 1, com. Okay? And now you double negate that whole thing, right? For not B or A. Why am I doing this? Double negation on 3. I'm doing that so that I have the negation of the left disjunct, right? Setting up for a disjunctive syllogism. So finally, I can derive F, right? So you've got to see that you should be able to get from this to the form of a disjunctive syllogism. Right, F is by ds on 4 and 2. 2 for disjunctive syllogism. Why? Right. A and B is equivalent to B or A. Right. That's the rule of com. So be familiar with that move. You can double negate that. And then this, of course, is the negation of that, right? So this is your P or Q, and you've got not P. So you've got the form of a disjunctive syllogism, you've got a disjunction and the negation of one of the disjuncts, so you can apply a disjunctive syllogism to infer the other disjunct. All right? Good luck for the exam, and we'll see you back here on YouTube.